Store-bought tempeh is expensive, and it rarely captures the complex, earthy flavor of traditional Indonesian fermentation. This image shows our target. We will transform loose beans into a firm, sliceable block, bound together entirely by a living organism. To build this, we only need 3 biological inputs: dry beans like soy or chickpeas, some plain vinegar, and a tempeh starter culture. We also have to maintain strict environmental prerequisites. That means absolute hygiene across all your tools, specific packaging materials like Ziploc bags and a toothpick, and a controlled heat source. By meticulously controlling these 3 factors, your ingredients, your hygiene, and your incubation environment, you can bypass commercial supply chains and engineer authentic tempeh right in your own kitchen. Take a look at this cross-section of a soybean. That tough outer skin acts as a barrier. It completely blocks external fungal spores from accessing the nutrients locked inside the bean. The traditional method for removing these hulls requires soaking the beans in water for 12 hours, followed by the labor of peeling them by hand. We can bypass that entirely. Once your beans are soaked, suspend them in water inside a food processor and give them exactly 3 quick pulses. The mechanical action sheds the skins while leaving the core beans intact. If you want to skip this step completely, you can substitute alternative legumes. Split peas, for example, come naturally dehulled. Next, boil the dehulled beans for exactly 30 minutes to soften them and make the nutrients available for the culture. You are looking for a strict al dente threshold. The cooked bean should yield to pressure, but retain a firm, solid center. Structural integrity at this stage is paramount. Overcooked, mushy beans will collapse under their own weight. If that happens, the mold is deprived of the physical support it needs to form a solid cake. Once the beans are boiled and drained, you enter a critical phase. Ambient, competing bacteria can easily hijack your batch if the conditions aren't perfect. Step 1 is a strict drying protocol. Spread the drained beans across clean kitchen towels and remove all surface water. Bagging wet beans leads to bacterial rot and an ammonia-ruined batch. They must be completely dry to the touch before you move forward. This acidification step is our primary safeguard. By mixing in 1.5 tablespoons of vinegar, we lower the overall pH. This creates an environment that inhibits invasive spoilage bacteria. Into this protected environment, we introduce our biological agent, the Rhizopus Oligosporus starter culture. You must mix this thoroughly. Every individual bean needs to act as an anchor point for the spores, so the culture can colonize the batch evenly. Removing surface moisture and dropping the pH eliminates the conditions bacteria need to survive, leaving the beans entirely to the Rhizopus mold. Now for packaging. Load the inoculated beans into a quart-sized Ziploc bag. Fold the excess plastic under so the beans are forced into a compact layer about 1 inch thick. To survive and multiply, the organism requires a steady supply of ambient oxygen. Look at this grid pattern. You need to puncturing the bag at precise 1-inch intervals on both sides to allow the spores to breathe. Next, we have to wake the spores. This requires a strict thermal operating window of 86 to 88 degrees Fahrenheit, or 30 to 31 degrees Celsius. You can maintain this heat at home using a dedicated folding prover, or by leveraging the residual heat of an oven with the interior lat left on. Now, the final requirement is entirely passive. Lock the environment down for 24 to 48 hours of rest. Watch as the white mycelium rapidly creeps across the gaps, binding the beans together. Controlling the airflow and maintaining a steady temperature provides the exact conditions required to knit these separate beans into a single solid block. To harvest your batch, simply cut away the plastic membrane to extract the fully colonized block. You should see a dense white fungal web that holds the entire structure together. When you pick it up, it should feel solid without crumbling. Run an olfactory safety check. It should have a clean, earthy, mushroom-like aroma. If you smell alcohol or ammonia, the batch has failed and must be discarded. This split screen compares a successful outcome on the left with the markers of a failure on the right. Notice how the failed batch is dark brown, slimy, and structurally collapsed. Once harvested, you can preserve the raw tempeh in the refrigerator for up to 10 days or store it in the freezer for up to 10 months. Following this biological sequence yields a block that is firm, fragrant, and ready for the fryer, allowing you to produce a protein that matches the texture and flavor of traditional Indonesian tempeh.